Interpretation of Acid-Base Disorder Part 1. Dr. Jalal, Mohsin, Uddin. MBBS, DTCD, FCPS Pulmonology. The points which will be discussed here. Normal values related to acid-base balance Slide 3. Basic facts related to pH Slide 4. Assessment of oxygenation status. Slide 11. Type of acid-base disorder Slide 14. Check for internal consistency of ABG reports Slide 21. Basic mechanisms of compensation Slide 23. Identification of acidosis and alkalosis Slide 24. Conversion of kPa, kilopascal, to mVhg Slide 25. Respiratory origin or metabolic origin Slide 28. Characteristics of compensatory response Slide 29. Normal blood gases arterial pH 7.35 to 7.45 power to 80 to 100 mm of mercury. The partial pressure of oxygen that is dissolved in arterial blood, PaCO 235 to 45 mm of mercury. Partial pressure of arterial O2. The amount of carbon dioxide dissolved in arterial blood, SpO2 95% to 10%, the arterial oxygen saturation. B-2 to +2 mEq, light, the base excess indicates the amount of excess or insufficient level of bicarbonate in the system. A base excess +3 equals metabolic alkalosis. A base excess -3 equals metabolic acidosis. HCO3 22 to 26 mEq, liter, 21-28 mEq, L, the calculated value of the amount of bicarbonate in the bloodstream. Basic facts related to pH. The acidity of body fluids is expressed in terms of hydrogen ion concentration. The hydrogen ion concentration is normally 40 nanoequivalents per liter, NeQ, L, and is usually expressed in terms of pH, which is the negative log of the hydrogen ion concentration, H+. 3 points regarding pH. First, pH and H+ are inversely related, as H+ concentration increase, pH decrease. Second, a normal pH of 7.4 corresponds to a normal H+ concentration of 40. Third, a reasonably accurate estimate of H+ concentration can be calculated from pH. By exploiting the nearly linear relationship between pH and H+, in the range between pH 7.1 and 7.5. Within this range, for each 0.01 unit change in pH there, H+ will change by 1 NeQ, L. Example 1. Q. If pH is 7.2, what will be there, H+ concentration? We know normal pH in blood is 7.4, which corresponds to 40 NeQ, L, H+, ion concentration. pH decrease, 0.20, so, H+, will increase. 4.01, change of pH, H+, concentration to 1 NeQ, L, so for 0.10 change of pH the change of H+, concentration will be 10 NeQ, L, so for 0.20, change of H+, will increase to 20 NeQ, L. So, if a pH 7.2 then calculated, H+ concentration will be 40 plus 20 equals 60 NeQ, L. Linear relationship between pH and H+ concentration. pH H+, 7.5, 32, 7.45, 35, 7.40, 40, 7.35, 45, 7.30, 50, 7.25, 56, 7.20, 63, 7.15, 71, 7.10. 79. The body always try to maintain blood pH within a narrow range between 7.35 and 7.45. If blood pH falls below 7.35, then the patient will suffer from acidosis. Conversely, when the pH rise over 7.45, the patient will suffer from alkalosis. But still, pH may be normal in mixed acid-base disorder and chronic respiratory alkalosis or alkalosis. Assessment of oxygenation status. Formula: 1 If PO2 plus CO2 140, it indicates patient is on supplemental O2 or it is a lab error. Formula: 2 If PO2 plus CO2 140, it indicates patient with or without supplemental O2 or it is normal or pathological. Calculation of expected PO2 according to age. PO2 decreases with age. Formula: 3 Minimal expected PO2 equals 80, age, 60. Example 2, patient of 80 years, minimal expected PO2 will be 80, 80 to 60, equals 80 to 20 equals 60 mm of Hg. Example 3, patient of 70 years, minimal expected PO2 will be 80, 70 to 60, equals 80 to 10 equals 70 mm of Hg. Whatever the age, if PO2 is less than 60 mm of Hg, it is always pathological. Pattern of disorder: 3 types. 1. Simple or pure disorder. 2. Mixed double type disorder. 3. Mixed triple type disorder. Simple or pure disorder: 4 types. Metabolic acidosis. Metabolic alkalosis. Respiratory acidosis. Respiratory alkalosis. 2 type of respiratory acidosis. Acute. Chronic. 2 type of respiratory alkalosis. Acute. Chronic. CO2 is washing out. Type of mixed double type disorder. Metabolic acidosis with metabolic alkalosis. Metabolic acidosis with respiratory acidosis. Metabolic acidosis with respiratory alkalosis. Metabolic alkalosis with respiratory acidosis. Metabolic alkalosis with respiratory alkalosis. Type of mixed triple disorder. Metabolic acidosis plus metabolic alkalosis plus respiratory acidosis. Metabolic acidosis plus metabolic alkalosis plus respiratory alkalosis. Respiratory acidosis and respiratory alkalosis never coexists. Type of disorder found in ABG interpretation, table: 1. A. Simple or pure disorder. 1. Metabolic acidosis. 2. Metabolic alkalosis. 3. Respiratory acidosis. A. Acute. B. Chronic. 4. Respiratory alkalosis. A. Acute. B. Chronic. B. Mixed double type disorder. 1. Metabolic acidosis with metabolic alkalosis. 2. Metabolic acidosis with respiratory acidosis. 3. Metabolic acidosis with respiratory alkalosis. 4. Metabolic alkalosis with respiratory acidosis. 5. Metabolic alkalosis with respiratory alkalosis. C. Mixed triple type disorder. 1. Metabolic acidosis plus metabolic alkalosis plus respiratory acidosis. 2. Metabolic acidosis plus metabolic alkalosis plus respiratory alkalosis. Respiratory acidosis and respiratory alkalosis never coexists. Check for internal consistency of ABG report. When you try to interpret an ABG report, you should know whether the report is interpretable or not. Here we can use Henderson-Hasselbalch equation in simplified way to form the following equation. Formula: 4, H plus, equals 24 multiply PCO2, represent lung activity, divide by HCO3, represent renal activity. Example, 4. Put the number in formula :4. H plus is calculated from linear relationship between pH and H plus concentration. So it is 36. 36 equals 24 multiply 55 divide by 36. 36 equals 36.6, so it is internally consistent. Basic mechanisms of compensation in primary acid-base disorders Table 2. Type of disturbance. Primary alteration. Compensatory response. Mechanism of compensatory response. Metabolic acidosis. Decrease in plasma, HCO3. Decrease in PCO2. Hyperventilation. Metabolic alkalosis. Increase in plasma, HCO3. Increase in PCO2. Hyperventilation. Respiratory acidosis. Increase in PCO2. Increase in HCO3. Increased HCO3, reabsorption by the kidney. Respiratory alkalosis. Decrease in PACO2. Decrease in HCO3. Decreased HCO3, reabsorption by kidney. Identification of acidosis and alkalosis. Conversion of kPa, kilopascal, to mVhg. In previous slide it is found that normal PCO2 level is 4.5 to 6 kilopascals. Express the level in mVhg. 1 kilopascal, equals 7.50 millimeters of Hg. 6 kilopascals CO2 equals 6 multiply 7.50 equals 45 millimeters of Hg. 4.5 kilopascals CO2 equals 4.5 multiply 7.5 equals 33.75, 35 of Hg. Whether problem is respiratory origin or metabolic origin. Expected changes in simple or pure acid-base disorder Table 3. Simple or pure acid-base disorder. pH, 7.35 to 7.45. HCO3, 1824 mEq, L. PCO2, 40 millimeters of Hg. Metabolic acidosis. 7.35. 18 mEq, L. 40 millimeters of Hg, compensatory. Metabolic alkalosis. 7.45. 24 mEq, L. 40 millimeters of Hg, compensatory. Respiratory acidosis. 7.35. 24 mEq, L, compensatory. 40 millimeters of Hg. Respiratory alkalosis. 7.45. 24 mEq, L, compensatory. 40 millimeters of Hg. Acid-base disorder depends mainly on change of HCO3 and PCO2 level. In simple acid-base disorders these changes occur in same direction. Remember. ROME. R equals respiratory. O equals opposite. M equals metabolic. E equals equal. Characteristics of compensatory responses. These processes tend to return the HCO3 and PCO2 levels back towards normal and thus help to normalize the arterial pH. Chronic respiratory acidosis, alkalosis may have, occasionally, normal pH, in the absence of mixed acid-base disorder. Compensatory responses require normal functioning lung and kidney. Characteristics of compensatory responses, continue. Adequate ventilator compensation for a primary metabolic disturbance may take 12 hours to occur, and adequate renal compensation for a primary respiratory disturbance may take several days to occur, 3 days. So premature use of formulae for the calculation of the expected compensation may lead to misinterpretation of data. The lack of compensation in an appropriate interval defines the presence of a second primary disorder. Characteristics of compensatory responses continue. Compensation through lungs occur rapidly than the renal system. Thank you all. End of part -1. Learning Pulmonology.